Okay, let's try to solve problem number 74. So for this problem, we have to rely on the same arrangement as in problem 73. So we just have to estimate the location on the y-axis where the charge Q will experience the greatest force. So we have to find out that. Again, we have already estimated this value f. Okay, so we have to kind of find the position of y somewhere here where the force is a maximum. So this is the force along y-axis that we already solved. So to find y, where Q will experience the greatest force, this charge somewhere here. Okay, greatest force, we need to take a derivative of this force with respect to y, because y is varying here. Okay, so we can set this as along y. So whenever x tends to y, we can take a derivative of this df over dy and set that to 0. Okay, so we will be able to get the value of y. So for that, we have the expression of fy, which is here. You just have to keep your eyes on these ads, and you just have to change that to y. So everything is same, just the derivative of this expression with respect to y. So the change is along y-axis. So this is constant, this one is constant, this one is constant, like there is nothing to do with the charge somewhere here. Whenever you take the derivative, the change along this y. So the Q is also fixed there. So you just have to take a derivative of this expression inside the bracket. So set that to 0. So solve that. As these 2q, k, and q, this whole expression cannot be equal to 0. So that means the product of these two expressions is 0 only if this is 0. So you can write this and take a derivative further. So I have rewritten this expression as the product of y and the product of y square plus a square over power negative of 3 by 2. If this goes up, then the indices will have to change, the sign of indices have to change to opposite, so it goes negative. Okay, so the product rule. So I feel quite easier to use product rule instead of using the quotient rule whenever doing derivative. So it's like a uv, the derivative of uv. So it's like u and derivative of b. This means whole of this. So the indices here and chain rule, it's easier. I think you all be able to do this. So this and the derivative, the indices -1. Again, there is a variable which is y, and you have to do the derivative for that as well. So y square, the derivative of this will be 2y times, so this is u times derivative of b plus, so the tone is for u now, so that is derivative of u times b. So derivative of u means the derivative of y, that's just 1. Okay, you can write that as well, 1, and the derivative of y is just 1, and just times b equal to 0. So this 2 and 2 goes away, and you will just end up getting this minus 3y times this y will be y squared, and this term, whole term, minus 3 over 2 minus 1 will be just 5 over 2, and the same value here. You can take a common among these two expression, the common of y squared plus a squared power negative 3 over 2. So you will be able to have these terms minus 3y squared times y squared plus a squared to the power minus 1 plus 1 to 0. So either, so these two, in order to hold this expression, either this has to be 0 or this has to be 0. Okay, so let's take this one. So in order to be 0, y square has to be equal to some value of a. So I think that's, you can, if you try to solve this, you will get a value which is invalid, out of range of our interest. And so you can solve this part, that is minus 3y squared times y squared plus a squared power minus 1. This goes down, plus 1, and you can just solve this. It's a simple algebra. So you will get y as positive and negative of a over root under 2. So at plus minus a over square root of 2, the charge q will experience greatest force. So it's like q is somewhere here and origin is somewhere here. Suppose a over root 2 is somewhere here and minus a over root 2 is somewhere. So obviously our interest will be this, because this will not give the greatest force to this q. You can easily see that. And so for part B, that's it for part A. For part B, we have to sketch this graph. That's kind of which I already discussed here. You have to just sketch that, the magnitude of the force on charge q as the function of y for positive, only positive value of y. So that's e over root under 2. So you can write the force along yx along this, and the y along x axis. So it's like a Gaussian, but it never goes to 0, you know. So this is the maximum force experienced by the charge q on the y-axis. So that's it for problem 74, part B. Thank you.